What's going on, y'all? Sean, the Master of Tutoring here, and in this video, we're still talking about rational functions, and we're specifically going into the topic of oblique asymptotes. Okay, make sure you like and subscribe for more pre-calculus videos. All right, so check it out. First of all, it's important to do a recap on what asymptotes are. So all an asymptote is an imaginary line that a graph approaches but never touches. Now, in a previous rational functions video, I talked about vertical and horizontal asymptotes. Um, but in this video, we're going to talk about oblique asymptotes. So, just to kind of give a taste of what they look like, it's similar to, of course, vertical and horizontal asymptotes in that it is an asymptote. But this is the way it looks. So an oblique asymptote is going to be basically like diagonal. So it'll be like this. Okay. So there's your quote imaginary line, and the graph is going to be kind of um like this. Hold on a second. Let me make sure I get this right. Yeah. So say for example that this particular graph also had like a vertical asymptote like so. Then this oblique asymptote would be diagonal and the graph would be something like this. And so you see what happens is with this particular graph, the line is getting closer and closer to this asymptote and to the vertical asymptote, but it's never ever touching. As you go, for example, like with the oblique asymptote, as you go more and more in this direction. So that's really like the equation of a line, which is what an oblique asymptote is going to end up being. It'll get closer and closer to that imaginary line, but it never touches, no matter how far out you go. Okay. Now, let's go ahead from here, and I'm going to erase this. If you need it, you just have to rewind the video. But from here, let us get into a real example. We'll erase this too. If you need that, just rewind, rewind, rewind. All right. Let's say that you have the following function. Let me see, where's the one that I wanted us to do here? Okay, yes, it's this one. So f of x equals x squared plus 3 over x plus 1. Now, how do you know that you have an oblique asymptote? This is how you know. You have an oblique asymptote when, say for example, you have um like a polynomial where the highest degree of the polynomial for each, like the numerator and denominator, the highest degree is represented like so. So a um, b to the m, and then you have down here. How do I want to represent this? Oh, I'm sorry, I didn't want to say b. It needs to be x. A x to the m, and then b x to the n. So what happens is you know you have an oblique asymptote when if you're given a rational function and ax to the m represents the highest degreed term of the numerator, bx to the n represents the highest degree term of the denominator. M, or I'm sorry, um, yeah, so m is equal to n plus 1. Or in other words, the numerator is exactly 1 degree higher. Okay, so that's essentially what's going on here. So if if m was like 2, then that means n would be 1. You know what I'm saying? So that's how it works. Or if it's x to the third up top, it's x squared at the bottom. And it makes sense because, like I said, an oblique asymptote is basically going to be like a line. It's going to be a line, and a line has a degree of 1. The x term is going to have a degree of 1, and so it makes sense because if it's like x cubed over x squared, x cubed divided by x squared is x to the first power. X to the fourth over x cubed, x to the fourth divided by x cubed is x to the first power. So it makes sense. This is how we find it. We're gonna do this division here. So this is x squared plus 3 divided by x plus 1. Let's actually do that division. So that's gonna be x squared plus 3 divided by x plus 1. Okay, x goes into x squared x times. Okay, and so x times x is x squared plus you have 1 times x is going to give you x. Okay, so all right, so let's subtract. So then you have here, this ends up being x plus 3. How many times does x go into x? So we're going to add a plus 1. X times 1 is x, and then 1 times 1 is 1. Okay, and so then that is, um, okay, hold on, am I doing this right? 1 times 1 is 1. And so then that's going to be, um, oh man, it would probably help if I wrote this down properly. I'm actually doing a totally different problem. But it's okay. I do the one I have. I just changed it from what I have here. So this would be 2. Okay. So now f of x in this case is equal to um, x plus 1 plus the remainder of 2 over x plus 1. Okay, so I changed the problem slightly from the one I'm working. Okay, now here's the deal. This is the equation of our oblique asymptote. Now, how do we figure this? If you look at f of x equals x plus 1 plus 2 over x plus 1, what you have to ask yourself is, what is the behavior? What's like the end behavior as we kind of go further and further out with this here? Like, for example, as x is increasing infinitely, what's going on? So as x is increasing infinitely, this part of the equation is getting very small. So it's going to 0, which leaves this part right here. Okay, and so that's why we're left with y equals x plus 1 is the equation of the oblique asymptote. So when you do the division, when you know you have an oblique asymptote and the top degree is 1 higher than the bottom degree, then do the division, and then the linear part of the resulting division is your oblique asymptote. Okay. Sorry, I had forgotten a little part there for a second. But yeah. So anyhow, That's how that works. Let me know if this video was helpful to you, and make sure you like and subscribe if you haven't already, and have a good one. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.